I've enjoyed exploring AI. And we've seen ever since ChatGPT has come out, there has just been so much innovation in the space. At the same time, there's a lot of hype and misinformation. So that's something I want to clear out. Right? This is going to be somewhat different from the hype that is provided. Based on my usual use of AI agents. So I just want to like, go to the next stage. So first of all, let's understand what is an AI agent in the first place, like from a fundamentals. So essentially, what it is an LLM which generates text that has been given tools, the sort of orchestration around it to be able to perform actions. So if you take an LLM, for example, like GPT-5 or Opus language models, essentially what they do is they will train on all this data on the internet and they'll be good predictors of like what the next word in a sentence might sound like. And that happens to be quite useful for a use cases. Now, what people started doing is they put these LLMs inside of a loop and they gave them actions, to like so-called like task for completion. So like we got planning and these models like I use not planning in quotes because it's not exactly planning, but when you give an LLM a task, it's able to like take down all the steps that it's supposed to do, and then it reasons through it like it just writes down what it should do, and then it like goes and does that. Now, how does it do that thing? It uses tools, and in order for it to use those tools, it needs information. So there's retrieval like tools, so to speak, there as well. So you have APIs, code, and databases, just like how you would have them in a regular application. Except you give it to an LLM, so an LLM is able to make tools, read code, see databases, see the data that's there, and able to make decisions. And in order to make better decisions, give it like information. So there's retrieval, augmentation, generation, flag, or you search, or you give it context, just by like putting it in the other context window. So that is somewhat dying out right now because all these LLMs have such large context windows. You can put a lot of things in the input itself. So you don't really have to go and search for information. You just give all the information right. And then if you talk about software sort of classes able to execute code, or in other cases also like let's say you want an LLM agent, like an AI agent to make a PDF, it can use a Python or a JavaScript library and execute that code to make that. And then we just have to monitor and approve changes. Like this is something might use cursor or plot code. And based on that, it will make better prompts to give the LLM better context format. So that is how that's essentially what an LLM is. It's an LLM in a loop. That is the way to context. And like we are also like we've come up with more tools like the whatnot to give it even more context and allow LLMs to run applications. And there are downsides to that. But we go to that has been catered for. You can go to the next slide. So the three main areas where I am most interested in AI agents right now and what's how does this that are like what like first of all like software. Like this is clearly one of the main things that LLMs are really good at. They're good at generating text and hence they're really quite decent at writing also for a very short amount of time. So you can make websites, full stack applications. Now that must be caveat, but it does speed up a lot of workflows. I think this is like LLMs have commoditized. The previous software used to be expensive, but now that is simply not the case. However, maintaining that software and keeping it running is one of those two things. Another thing that I see LLMs really disrupting, and like AI agents would be cybersecurity. Like in general, this space is just really vast and there's lots of vectors of attack. Now having AI agents can create payloads and just do all sorts of attacks that you couldn't do at scale before. So that is something I've been exploring a lot. And then in the enterprise, there's a lot of grunt work that can be automated with AI agents. Making presentation, so summarizing documents or creating knowledge bases. So those are the three things that I think AI agents in my had the most positive impact. And like everyone thinks that you add AI to your workflow and instantly you fix all the problems in your organization. But that's simply not the case. Like AI agents make good workflows better and it won't fix broken ones. Like if you do not have the proper base, the proper structures in place for your work to happen, just adding an AI agent will only make it more complicated because it's another variable that's added into it. So make sure that your workflows are already solid before you add it. And one of the main reasons why AI agents like compared to like other benchmarks that is like okay on SW bench, like it's getting 90% accuracy, for example. But in the real world, LLMs still tend to make mistakes. So the reason for that is that the way LLMs are evaluated, like the benchmarks that are there, they're very simple, isolated tasks. And in the real world, those tasks are not exactly like probably going to one's corporate requires planning and context. And if an LLM does not have access for that, it's simply not going to do. So in the real world, multi-step chain workflows, things that are dependent on each other, and if one step goes wrong, then the entire thing can go waste. And that's something that LLM benchmarks with like 10 numbers. And also, when you are doing LLM benchmarks, they're very curated and inputs. Whereas in the real world, like data is noisy and ambiguous. So you don't have to, like in LLM benchmarks, it's very meaningful. And also, like, again, LLM benchmarks are not necessarily represented over the real world. So, again, that causes issues when you try to use it for actual purpose. And again, LLM benchmarks, very controlled environments. And obviously, the real world is far more complex. There's multiple people involved, lots of complexity that you have to take into account. So, which is why you see generally when you use something like a lot of people person, like LLMs just hallucinate and they try to solve problems that are not even there. That's simply because of the way they're benchmarks. Like you optimize LLMs for just solving single problems. And that's not that doesn't work very well. So which is why whenever we try doing any sort of task with an LLM, you make sure that you take small baby steps instead of giving it one giant task. And like as how I talked about there, what you can do to monitor these LLMs. So yeah, most global problems are yeah. So most global problems are context problems. They're not necessarily as task-oriented problems. And benchmarks look at. That's the essence of why there's like a huge gap in the AI agents and with what happens. So I think one of the most common failure boards for LLMs is false positives. It's when an LLM tries to find problems that are not even there. Because, like, again, this comes back to the benchmark. LLMs have been wired just over solve problems. And they're not necessarily speak of as much data to say no when there are no problems. So, which is why, especially if you use the older cloud models like Opus 3.7 or even Sonnet 3.5, like they tend to just write so much extra code and they tend to change things that you didn't even understand. So, like you'll see hallucinated dependencies and packages, like things that you didn't even want in code base, confident but wrong classifications, like pointing at problems that don't even exist, or being fabricated data. This is another big one. And like let's say if you're running an organization, this fake data, like in the case of finance, for example, can be very detrimental because this is sensitive data, right? What would have been very detrimental. And then also over engineering, like for very simple tasks, over engineering development. And also another problem is like when you have multi-step workflows, when you have one error, it just cascades and it turns into this whole mess. And then the agents follow. So this is why guardrails are important. Like you have to monitor AI agents. You can't just accept all the code or all the changes that it makes. So that's something you have to be careful about. Okay, like AI agents not a simple bullet. Like you have to understand why it freezes and where it freezes and how to go start tackling that. So small input changes can cause widely different outputs. For example, if you're in an organization working with multiple people, the same input can give you quite different outputs for a variety of reasons. So you have like garbage and garbage out. Like the whatever input you give the agent, whatever tools you give it, is going to dictate the quality of the code that you can do. security is like install this with cloud. Like it has taken the world by storm, and that's amazing. Everyone is excited to have the known personal AI assistant. But the problem there is if you give like almost root level access to your sensitive file system, like the open cloud can do anything. Like recently, one of the VPs at Meta was running open cloud, and open cloud just decided it's going to delete all the emails. Like even if you tell it like in the context that be careful, things like that. Because LLM is still prone to hallucination, and when they go rogue, it's very hard to stop them. So I have to be very careful about that. Also, like make sure like your environment variables or your passwords are not leaked when you're working with the agents. So you have to put those guardrails in place. That's very important. And again, like these are brittle systems, like in the sense that if one tool or one step of the workflow has had a mistake in it, it can just compound exponentially and the entire mechanism can be degraded. So it is very important that you monitor what your AI is doing. So again, the two most important things that I found most useful is like adding guardrails and observability. Like if you need to be able to see what your AI agent is doing, then only you'll be able to like add all the guardrails and use that AI agent effectively. Like, and the thing is now these LLMs are only getting faster and faster. Like if you use Kimi K 2.5, 2.6, like you see it's very, very fast. So when I try to code, the right code, you don't even know like what is being changed, and that can be quite fast because then you put in changes, you have always better programs. So you have to trace the decisions that the LLM is making, like do the logging and whatnot. And as far as guarding is concerned, like we want to give sensitive information to your AI agent. So that's like your AI agents box and be careful about if you want to give good agent system. So some of the patterns that like good and like this is still like very new for times. But things like human in the loop, like you need to have someone in the loop when an AI agent is operating. Otherwise, again, it's all the issues that we mentioned are going to make sure that the tools that you give to the AI agent are not random tools that you just see on the internet and because they can do malicious tasks. I mean, this is very basic stuff. Like even with regular software, you're careful of like what you install on the computer. So then why would you also give uninitiated access to an LLM on what internet? Also, like engineer the context properly. Like make sure you give the right information to the LLM to make the correct decisions. And then also like try to like break down the tasks that you're doing. So instead of giving like big tasks that are like multi-chain, give smaller tasks to the LLM that it is able to like, solve one by one and carefully monitor what is true. So again, the AI agents will make good workflows even better, but they will replace like the answer was already good, but they won't fix it. So that's the game. Again, like just coming back to like, what can make agents more effective. Make sure that you give them like the proper sandbox. You don't give them uninitiated access to your entire file system, and you don't just like select like give it access to all the code that you have for the also, make sure that the evaluations you're doing for these effectiveness of the game, make sure you actually see the business impact of it, and not just because some XYZ benchmark said that it has 90% accuracy. So like that is something you find in a qualitative field as it goes. Another thing is like you need to escalation pass. Like let's say if there is use cloud code or open code, you that when it tries to delete a file, it asks you once that when can it delete the file or not. So these sort of escalation paths are very important. It's part of the guardrails. And again, monitoring. Like if you don't know what your AI agent is doing, then that's really hard. Like if you have to be in the loop. These systems are not fully autonomous. So effective agents are built on trust more than anything. So don't go based on the benchmarks. Use it to review it and see how you find you get a for particular use. So we'll just summarize this again. Don't go based on benchmarks like it finds it very enticing like Google's like new models are suddenly like 90%, like software engineers solved and stuff like that. That is simply not the case. Like most problems in the real world are context problems. They're not necessarily just like fixing tasks. False positives like are very common with LLMs just because of the way they're engineered and what they're optimized for. So guardrails become essential. Agents will amplify good workflows, they don't get the bad ones. So like make sure you have good workflows. And again, garbage is garbage. Like, the data and the context that you give your LLM is the single most important. So be careful. Observability again, very important. If you don't know what your AI agent is doing, then it's quite bad. Because if you just need to like tons of issues. And again, just understand that AI agents will not take your job. Someone that uses AI agents effectively to do their work will replace someone else. So LLMs like this are useful for these variety of use cases, but like in their own periphery. So the question is whether agents will replace humans. It's how we design. And that's simply what we should be focusing on rather than like unbased like that's that's a great